All righty. Thanks so much for joining me, everybody. This is going to be a jam-packed session. If you've ever been on a webinar before with me, you know that I talk a lot and I talk fast. I really want to get your questions into this webinar because that's what makes it most interesting. And I'll have a little surprise for you on that front in just a second. But first of all, we're here today talking about the best practices for monitoring Docker. So at a glance, here's what we're going to cover. Fundamentally, why is Docker a different monitoring challenge? Why are you here in the first place, right? Okay, so great. It's a different challenge. Docker is this really important revolutionary platform. What do they offer for monitoring themselves? And based on that, we'll go into kind of breaking down what are the key elements you need to consider for production scale monitoring. So we'll dabble around the edges and what you might try when you're first getting started with Docker, but then we'll start to kind of unravel the picture a little bit and see what you really need to do as you start building your transition from your legacy platform to a Docker-based platform. And in order to cover that, we'll cover things like how you build dynamic instrumentation, how you get application metrics and not just infrastructure metrics, how you think about orchestrators like Docker Swarm and Kubernetes, and how you leverage them to create service-level monitoring, and how you think about alerting in this environment. Okay, so before we get started, I wanted to get some information from you from the perspective of the audience at large so that I can do a better job tuning this presentation. Where are you right now in your Docker journey? And, you know, pardon the rough categories, but that's the best we can do in a poll. Are you exploring? Are you using this in development? Are you actually using it in production? Or are you just not planning to use it at all right now? And this is more kind of a research research experiment for you to be here on this webinar. We'll give you a moment to answer these questions, but in the meantime, as I mentioned earlier, I'm really into questions. So I would like to encourage you to ask me lots of questions, and I want you to stump me. I would like to walk away with at least one question where I was like, you know what? I don't know the answer to that. I've got to go back and find the answer for you. If you can stump me in a question related to Docker monitoring, then I'm going to send you a Sysdig t-shirt. So please try early, try often, get those questions out there related to Docker monitoring. I will answer questions as they come in, and we will, we'll try to take as many as I can get from there. All right, Chris, are we good on the polls?
Looks like we've got just a few people. We've got one person that's kind of in progress. I'll go ahead and set it to close now. Give them just a minute. All right, poll results should be up now.
All right, so we've got we've got about a third of the audience using in dev right now, a third exploring, about 15% actually using it in production, and 26% have no answer. So they have no idea why they're here. That's okay. You'll learn good stuff anyway. By the way, these results are about on track for what we see. We kind of see this third split right now, with third using it to some degree in production, a third using in dev, and a third thinking about their journey. Awesome. Great. Okay, so let's dig into Docker and what's so awesome about Docker and what challenge it creates. First of all, Docker has been fantastic for development. The Docker platform is essentially an abstraction layer for your code, which allows you to make your code more portable. Right? It makes it easier for your developers to create an environment on their laptop that looks more like your production environment, easily spin up, spin down those containers, move them around. Fantastic, right? You can kind of do that pretty effectively for developers. The orchestration layers that have been built around Docker make it really easy to move and scale these containers without intervention. And then you can build services made up of many containers. All of this is built around this idea that you can build this small, efficient, lightweight, portable black box container. Great for developers. But for operations, you actually want to be able to see inside the container, because it's not so important how the container itself is performing, it's important how the application inside the container is important. And that's where the black box that was so beneficial for developers becomes a limitation for operations. All right, so we need to peer inside that container, and we need to understand how it's performing. We need to understand, just think about it, we need to understand how the host is performing and how the network is performing. We need to understand how the container is performing, and then we need to understand how the app inside the container is performing. So let's start by leveraging what the Docker API provides us in order to look at some monitoring data. The Docker API has a Docker Stats API. You can see a small screenshot here of a GitHub gist with Docker Stats API output. Easiest way to run this is via curl command. I'm going to hop over to a terminal window here. Let's clear this, and I'm going to make this a little bit bigger so you guys can see it. And we're going to run this command. So we're just running a curl command. I'm pumping it to this Unix, the Unix socket for my Docker socket. I've specified a particular container, and I've turned the streaming function off just so it's easier for us to see the output. And then I'm piping it through a Python JSON prettier tool. It takes a second or so, and what you see here is the output. There's, you know, I always go back and forth on this data. You know, at first glance, it's like, oh, wow, you know, I ran this one command, and I have a lot of data about this container, right? So if I pipe all the way to the top here, you'll see, okay, so you've got your bulk IO stats. Let me scroll down here. You've got your CPU usage, your per CPU usage, your system usage, and your memory stats. So, and then finally network, of course. So, you know, CPU, memory, network is kind of covered here. Very generic though, like, okay, great, I kind of have some basics here. They're not really mapped to a model that, you know, that's truly human understandable. So you need to do some math on this just to make it easier for you to process and read. Again, it really doesn't tell you anything about the system at large. It's useful for maybe if you're troubleshooting an individual container, but not particularly useful if you're kind of trying to look at a complete distributed system and understand how things are performing. So let's hop back here. So great. That's, you know, that's great. I guess that's great. Let's put it that way. It's an okay way to start. It's an okay way to tap some data that's very generic. There's another project that's out there called Cadvisor. I'm curious from the audience, has anybody heard of Cadvisor? Let's take a moment and see if anybody has heard of Cadvisor. Yes? No? Anyone? Okay. Reminder it hasn't. A few people haven't. It's an interesting project from the folks at Google. It was designed as an additional container that basically taps the Docker API. So all that information I was showing you before, what the Cadvisor has done is they've put a tiny front end on the Docker API, and you can see a screenshot of it here on the right. What it does is gives you per second stats. There's really no trending. It gives you about a 2-minute window of the performance. No alerts, no dashboards, but at least you can visualize the performance of a host and the individual containers on that host. Chris, one participant said he lost audio. I just wanted to check, make sure you can hear me okay.
Yeah, I can hear you just fine. I'll see if I can help Curtis get that sorted out.
All right, cool, thanks. Great. So Cadvisor is an interesting way to, you know, kind of resolve some of those issues I described with the Docker Stats API, and just give you, you know, kind of like a more human-readable view of that information. Even though I still don't believe it will solve your distributed monitoring challenge, it will help you in terms of getting started and understanding what's going on a host with your containers and looking at it from that perspective. All right, I'm going to stop very quickly here, take a sip of water, but I'm going to use this opportunity to see if the audience has any questions so far on the material we've covered in terms of the Docker Stats API and Cadvisor. Okay. First question from Shri is the Cadvisor per Docker instance or across the cluster? It's neither of those. It's per host. So Cadvisor is an individual container that runs alongside the other containers on your host and processes information from that Docker daemon. So one per host. Great question. Cool. Okay. Thanks for the questions. Please keep them coming in. When I was going through this process myself and learning about Docker monitoring and instrumentation, I felt like when I went through these steps, I kind of left with more questions than I felt like I had answers. Cadvisor is kind of lightweight. Cadvisor is lightweight, but it's very limited. Right? It's limited to a host. Mitch is asking if that monitor can authenticate with OAuth and so on. No way. Like this is really, these are like simple open source toys that people have made to kind of help you understand a little bit of what's going on with Docker. In truth, it's not, none of what I've shown you so far is a kind of production ready system. First of all, okay, great. How do I build really dynamic and transparent instrumentation that's going to work across this distributed environment? No matter what I've shown you so far, or everything I've shown you so far, none of it deals with application-specific metrics. How do you monitor your applications in addition to Docker? How do you know that your MySQL queries are running well? How do you understand what the response time of your service is? And if you're truly trying to transition from your legacy monolithic app to maybe a microservices architecture, do you have a monitoring solution that can both understand containers and then a microservice architecture, possibly in multiple clouds, private and public? And then finally, if you're going to really move to this containerized environment with all the benefits of containers, are you going to have an alert model that matches? An alert model that deals with like the dynamic scaling and portability of containers? All of these questions to me seem to be open still, right? These questions kind of I didn't feel answered by just exploring what Docker had for me. All right, so let's get serious now. Let's start talking about how you do this at scale. As an aside, I'm going to be demoing these best practices with Sysdig, and a little bit about our core product here is, not surprisingly, given this, this kind of topic that I'm on, we're a container native monitoring platform. We're built for any infrastructure and app, and we're built with Docker monitoring in mind. So what that means is we are container native. We understand the basics of how containers work, and we can see that built into our app. And as a result, we can also monitor legacy VM and bare metal environments. And what you'll see with our product is VM and container friendly, scale out workflows across microservices for both devs and ops teams, and the product itself can be deployed on-premise or in the cloud. Cool. So the first thing I wanted to talk about here is instrumentation. Instrumentation is really important. As I mentioned earlier, it's important that we see not only some basic metrics like CPU, memory, network. Then I also want to see application metrics, things that my apps are already exposing through APIs. Very common for open source components like Apache, Tomcat, MySQL, HDFS, RabbitMQ, et cetera, et cetera. And then I also want to see custom metrics, so StatsD or JMX metrics that my developers are exposing through their code. And I need all of that together in a single place in order to truly understand what's going on with my application. What Sysdig has done, as opposed to just relying on the Docker Stats API, we realized that that data was really limited, and we'd be limited to what Docker had the technical capability to expose. So instead, we developed a new form of instrumentation. It's a transparent type of instrumentation that leverages a basic facility in the Linux kernel called tracepoints. And from that, we can see every single system call that every container and every application makes. Imagine that for a second. With this one point of instrumentation, we can see every single system call that comes from a container or the application inside of it. Not only can we see those existing containers, but as Docker decides to create new ones or take containers away, we see that as well. So we can discover containers as they come and go. We do this by running an agent container alongside all of your other containers, whether they're Docker, Rocket, or other forms of containerization. We then can collect all these metrics that we find via system calls, and we pump them up to our agent container, which then can go off to the cloud or to an on-premise solution for monitoring, troubleshooting, and analytics of your system. As I mentioned, this is focused on Linux today. There are plans for us to port this to Windows in the future, but we don't have a particular date for that, so I can't give you a date for that right now. Great question, Mitch. Thank you. All right, so let's see. Mitch asks if you get a T-shirt. Well, Mitch, you got to stump me, man. You got to stump me. I like your enthusiasm, so keep going. No date, Mitch. No date on the Windows support right now. From Charles, he asks, how does this work with Kubernetes? Stay tuned for that, Charles. I'm going to demo that a little bit later in this presentation. What I'd like to do here is demo this idea of dynamic instrumentation for you. In order to do this, let's hop into the Sysdig environment here. Okay, so what you see here is we're in an empty Sysdig environment. By the way, this is our cloud service. As I mentioned, we also offer this exact same software as on-premise software. So if you work in a highly regulated environment, you prefer to work in your private cloud for security or management reasons, you can get this exact same experience on-premise. Not a problem at all. Okay, so you can see here this environment's a little bit sad. There's no data in it. You can see that no data available menu. So let's show you this instrumentation. As I mentioned, the idea of instrumenting with this transparent agent is very simple. So there are two steps generally, is you have to install kernel headers on your host. I've already done that on my host, so I'm just going to skip that. It's really a one-step command. And then you have various install methods. So here is a plain vanilla Docker install method, a Docker run command, which you can just copy and paste. Here is a plain vanilla Linux install. So if you're not using containers, that's how you can use our product. And then we have various instructions for common methodologies: Kubernetes, Mesos Marathon, VCOS, OpenShift, ECS, Google Container Engine, and so on. You can, of course, always install these manually. What installs like these orchestrator installs generally do is make sure that every time you spin up a new host with a worker, that the monitoring agent is automatically deployed. So we're going to take this command, hop back over to my terminal here. Let's see what I've got running here for the first. Okay, so what you can see here on my host is I've got an HA proxy. I've got a couple WordPress front ends. They're basically acting like my web app, and a MySQL backend. So I've got a very small environment here. and I'm going to run, let's see here, there's my Docker run command. I've removed the -d flag. The -d flag, for those of you who know Docker reasonably well, run a process in the background, and I'm running this in the foreground so that you can see what the system is actually doing here. So let's click this. All right, now we're grabbing, Docker is finding the Sysdig agent, installing it, and within seconds, it begins auto-discovering your environment. So it's looking at our environment and figuring out what containers are running there, what applications are running there, and starting to dissect those system calls to see what kind of data it can find for us to monitor. All right, so let's hop back into this environment, and we'll hop into an area called the Explore tab. Explore is like HTOP for your entire distributed environment. It's an incredibly dynamic way for you to troubleshoot, and one of the real kind of powers of our product. And you can see we already have our host here, and we see some basic network, basic monitoring data: CPU, memory, network, file system, kind of basic stuff. Now, the way we've set this up right now, and this is entirely configurable, I'll show you this in a moment, is you're starting by host, and then you're looking at container. What that means is I can drill down here, and I can see all the containers running on the system. And wouldn't you know it, we've got an HA proxy, we've got our WordPress agents, and we've got MySQL running. Now, as I mentioned, still this is useful. Now we're getting down into these individual container metrics in a way we can understand them. Now let's start getting into the application itself. Now, you saw me do the instrumentation. I didn't do anything special to tell Sysdig what I'm running, but let's click on MySQL, and you'll see what we get here is an overview of, the default view here is overview by process for MySQL, and it tells me, network, memory, CPU usage. Great, that's useful. It's still infrastructure oriented. Let's start with a service overview. So maybe not the best view given I just started this up, I realize right now. But what you can see here, I'll give it a moment. There we go. It's just covered by my chat windows. What you can see here is now we're getting into app-specific stuff, and we're starting to see, okay, we've got containers, we've got request counts, and the main chart here is showing us response time versus resource utilization. This is incredibly useful because now I'm starting to think about the performance of my system. If I wanted to highlight this, we could zoom in here and kind of get a flavor for this. Of course, this isn't a very complex system. Now, of course, this is MySQL, so let's dig in and look at some MySQL specific metrics. I can click on my pre-built MySQL view here, and now, even deeper than before, I'm getting into requests, errors, and look at this. Top queries, top tables, slowest queries, and slowest tables. So now I'm getting into deep MySQL specific metrics. And while I'm showing you for MySQL in particular, this is true for any of the applications we support. And if we don't support it, you can write your own kind of what we call an application check in order to get you this level of information from the application if you've written a custom application. Let's see. Okay, lots of questions are coming in, so thank you. First of all, I'm going to try to get to as many as I can. Let's see here. Whew. Oh, man, okay. Parsing. Galen asks about other Unix variants. Today, primarily, we're all focused on flavors of Linux. That's where we focus, so that's where you'll find the most success with us. We will grow that support over time, similar to the Windows response before. Samir asks, can we use Sysdig to take control of the container? Can we stop any container using monitoring UI information provided here? I'll show you one way you can do that in a bit. We can't directly do that today, but I'll show you how you can make that work with alerts and just a little bit of glue. Satoris asks, what's the performance impact of the agent container. The performance impact of the agent container is generally limited to about 5% CPU and 512 megs of RAM. The CPU limitation is configurable, and if like you have a really busy system, we'll kind of lower our own priority in order to make sure your apps get the resources first. Matthew asks, does this cater for a security-related view for containers? Yeah, so some people do use us for a security-related view in particular, you know, kind of leveraging the same data. We can talk a little bit more about that later or offline. Later, if we have time, offline. Let's see. So let's see. Is it available for Cloud Foundry or OpenStack? Yeah, we work with the Cloud Foundry folks very frequently, so we'd be happy to support that environment. Okay, so wow, so many questions coming on. This is great. So Shri asks, how does it dynamically instrument? That's our magic. It's that thin, transparent trace points layer that I showed you in the slides. We do not depend on the Docker daemon for collecting this information. It's at the system call level. DP asks about overhead of the software, which I mentioned earlier. Yeah, so Cadvisor can really use up a lot of resources. The Sysdig agent is performance tuned. Samir is also asking, are these features available as open source? So what the UI you're looking at is not open source. Sysdig has an open source container troubleshooting tool available at sysdig.org, which you should check out. It's super useful for troubleshooting a container, but not doing this kind of aggregated view. This is our commercial product. We do offer free trials of this product, so you can do that at sysdig.com. So some folks were asking about the resource utilization of this particular of our agent. So let's just look at this overview by container. So you can see here I selected the Sysdig agent, and now we're getting a quick overview. So you're seeing for this very small host, I'm using about 3% of CPU. Right now, I'm using a pretty high level of memory usage. So the reason it's so high in memory usage is this is a T2 micro on this is a T2 micro on AWS. So naturally, this is not really designed to be a production system. But this gives you a flavor of what I was describing in terms of CPU and memory disk and memory utilization. All right, cool. So what you've seen so far is how, with one simple instrumentation command, leveraging our unique instrumentation, you can see not only the host. You remember seeing that IP address in the Explorer window. You can see the individual containers, but you can also see the applications running inside the containers. All of that is auto-discovered, which is essential in a containerized environment. Because if you're not auto-discovering your apps, what's going to happen when an orchestrator comes along and starts automatically scaling up and moving those containers around in order to support your scaled out workflow? That's where the idea of monitoring microservices comes into play. If you recall earlier in the presentation, I said Sysdig's approach was to fundamentally rethink monitoring around the concepts of Docker and the microservices that you build, the microservices that you build on top of Docker. So imagine this scenario where you've built these services, service 1, service 2, service 3 in this simple example, and your orchestrator, like Kubernetes or Docker Swarm, or someone mentioned Docker Compose earlier, you could certainly use it with Compose, kind of spreads that out among different hosts. Well, this gets really hard to ask the question, how is service 1 doing? Imagine service 1 is your database backend. And you want to just understand at large, how quickly am I responding to queries? What's the service response time? The way you want to look at that data in order to truly understand it is to aggregate the information based on those individual services and then present the data to the user in more of a logical way. So not physical. IP addresses don't matter because your containers were spread out over so many IP addresses. Instead, the logical deployment of a service is really what matters. So the example here is, what's the response time of my Cassandra service that's currently distributed over 3 data centers? What are the slowest queries? How do we get there? We get there through Sysdig's other kind of core functionality, which is a deep real-time understanding of orchestration metadata. So we call this service vision, and service vision is the ability to automatically tap into your orchestrator and use their concepts of labels or tags to dynamically group the data from containers into the views you care about. Now, not surprisingly, I'm going to demo this functionality to you and show you what this looks like specifically in a Kubernetes environment today for whoever asked about Kubernetes earlier. But before I do that, it's time for our next poll. I would love for everyone to answer. Last poll, we had a 26% no answer rate. Let's see if we can get that down to a 10% no answer rate. What are you using an orchestration system today? So you can kind of see the options. These are the most common ones. Feel free to answer other and then chat in what you're using if you are. I'm going to take a sip of water here before we go on to the next demo. So Sotiris, hope I pronounced your name correctly. I probably didn't. Mentions that he's using AWS ECS. And a couple more questions coming in while we're answering the poll. So a couple questions about, do you need to run this agent on all servers? Yeah, any server you want to monitor. But the beauty here is that you're running an individual container per host. So what you'll see is that legacy solutions actually make you go in and try and instrument each and every one of your containers. And that is an entirely untenable process. Containers were not built to work that way. This model allows you to drop a single agent on every, a single agent container on every host, and you automatically see how everything's performing out of the box. It's much more powerful. DPS, is it a cluster of agents? So it's not really a cluster of agents. I'm not quite sure what you mean by that, but there's an agent per host. So if you're running a cluster of 20 machines, then you would probably be running 20 agents, one per machine, in order to instrument the entire environment. All right. One more question came in: microservice monitoring at the API gateway level versus microservice monitor. Partially. So you're trying to create a comparison tree. The microservice monitoring is one piece of it, and you know, when I go into the next part of the demo, I can show you how you look at your slow HTTP responses, you know, your endpoint responses. But of course, that's only one piece of the puzzle. You know, how are you know, how's your Cassandra agent doing a garbage collection? How are your containers doing in relation to your container limits, and so on and so forth? Those are all essential to the full stack monitoring experience. So that is, you know, that's kind of something essential for you to consider. And Sotiris asks, what about failures? If the agent container goes down, data is lost when we need it. Yeah, so our agent has certainly been hardened for you know, kind of effective usage and kind of staying up in rough cases. You know, if you're using an orchestrator like Kubernetes and so on, they'll also be keeping track to try and keep the agent up. So we see very few cases where the agent container goes down and the host stays up. So in most cases, what happens is the whole host gets killed for one reason or another, and then of course our agent absolutely goes away. The good news is in our system you can alert on it. Okay. So many questions. So good. All right, Chris, thanks for moving us to the results of the poll. Really nice spread here, and kind of a little bit. This is a little unusual. I would say that it's so here we're seeing Swarm and Kubernetes tied, and other coming in and you know, kind of pole position, if you will, and none with the highest answer. Now, Chris, I'm a little disappointed. No answer is at 25%.
Yeah, you know, but we did at least drop below the 26% that we had on the previous one. So we're improving as the webinar goes on, which I think is a good sign.
But at this rate, we're going to have to do about 72 polls to get us to where we want to be. All right, so let's go on to our last. Actually, I think I'm going to do one more demo after this. I got another idea here. So let's hop over to our environment. I'm going to close this environment out that we were looking at before, and I'm going to go to a larger. I'm going to go to a larger environment here. Let me show you. Sorry, pardon my clicking. Let's see. Now this will give you a better flavor of how you know, you really want to monitor containerized environments at scale. What you're looking at first here is a dynamic topology map of your physical hosts. This is dynamically created. So once an agent, a Sysdig agent exists on your host, it does see all network traffic and can create this map for you. And we have a feature that we call Google Maps for your infrastructure, which is I can zoom into this container, and actually I can see the individual containers running on this host. Let's see here. Let's take a look. All right, cool. So we can see here, it's very messy. I will be the first to admit, wow, this is a mess, and you can see stuff talking everywhere, you know, within the host, outside the host. This isn't actually that useful, to be totally honest, because the orchestrator, in this case Kubernetes, is deciding what containers run where. And it's not doing it in a way that is incredibly easy for a human to read. So let's instead use that concept that I was describing before of the metadata from Kubernetes to organize this information into applications that make sense. So I'm going to switch over here to the Kubernetes, what we call a logical map. So the first thing you see here is like, oh wait, the grouping's very different here. There are no IP addresses. They're instead what we call Kubernetes namespaces. There's the default namespace, there's dev, there's prod, and there's the kube system. Let's look into prod, okay? All right, now if I zoom into prod, what do I see? Oh wow, okay. This makes a lot more sense. You can see here I've got two applications running in prod. You know, you can see these two flows of data. One of them is an HTTP-based application with a MySQL backend. It's got two containers making up the WordPress application and one making up the MySQL. And then you've got a Java application, a custom Java app, which has 4 containers or 4 units in it that is backended by Cassandra, Mongo, and Redis. Probably an unlikely combination to be using all 3 of those, but kind of useful for our demo purposes. So this is very powerful in the way that now I can look at this as my services are working. All of this is customizable, so I can decide what information I want to be looking at here. Right now, we're looking at memory consumption across those containers. You know, it could be information that we're interested in looking at, like service response time, CPU utilization, totally configurable. We could spend a long time showing you that. Now, someone was asking before about kind of stuff like web endpoint monitoring. So let's go into a dashboard here of, in this case, this is a custom created dashboard around the web app. And you can see here there's a scope, Kubernetes namespace equals prod, and so on and so forth. Here you see our slowest endpoints. So if you're monitoring a microservice, basically the endpoint consumption is what you would probably care about the most, and understanding the performance of that. But of course, there's a lot more data you need to effectively monitor this service. You want things like, you know, how am I doing on requests? What's my max request time? What does the network traffic look like? What do my status codes look like? You know, average and max request time, so on and so forth. So totally customizable, and the ability for you to get from the layer of, we get all the way from the layer of what does my service performance look like, what's going on inside my app, down to host, container, network. All right, let's get a little bit deeper. You know, Robert, you asked, tell me about data collection here in the system. Okay, so as I mentioned earlier, the Sysdig agent container is responsible for extracting the metrics from your system calls. It bundles them up and then sends them off to the back end. The back end that I'm demonstrating right now, or the app that I'm demonstrating, is our cloud service. You can send all the data to our cloud service. We manage it all. You log in via the URL you see up top. Or you could run this as private software in your private cloud. So you'd have, you know, your custom deployment, and you would have a different URL, and your data would be private for you to manage. We store data forever. So I just want to clarify that. You'll never have to worry about data going away. What we do is we take older data and we roll it up. So it's less fine-grained, but you'll be able to trend over the entire history of your data. And that makes it's very, very powerful. Okay, so you can see here we're back to an Explore view that really kind of starts with the basics, right? Just like we did before, we've got hosts, we've got containers living on that host. All right, now let's instead change what we call the grouping. This is using metadata to regroup the containers into something that makes more sense for us to troubleshoot with. So I'm going to use these Kubernetes deployments, which go by namespace, deployment, and so on. Now, this is, of course, specific to Kubernetes. You see here we've got pre-built views for AWS ECS, Docker Swarm, Marathon, Mesos, so on and so forth. Okay, let's apply Kubernetes. You can also create your own, by the way. These are just defaults. I'll show you in a moment how you can create your own. This right here, this grouping now looks a whole lot like what we were looking at on the topology map. And I can drill down into prod, and I can see all of the services that make up my prod environment: Cassandra, the Java application, Mongo, MySQL, Redis, and so on. So now we have a really powerful way to start troubleshooting our system. Let's see here. Right now I'm at a 1 hour granularity. Let's say I want to switch to 10 minutes. It happened instantly. We're looking at a 10-minute granularity. Let's suppose I wanted to change this grouping. Now I'm actually not interested in namespaces. I care about like MySQL across the entire environment. Let me just kill this namespace grouping. Great, and now I can see it's aggregated, and I've got MySQL across the entire environment. Let's suppose I want to drill in and understand MySQL performance. I can click on MySQL here, as we did before. We used MySQL before. Maybe I'll switch it up and use WordPress for HTTP. Let's start by looking at a service overview. Yeah, so here you can see some really interesting results, which kind of might lead you to start troubleshooting a system here. Where look at this, where we see the spike in your average request time going up, where your at the exact same time that your total bytes being sent through are going way down. So this is a place where you might want to drill in further to see what was happening at that time in the system. We can get there in a moment. We'll show you a troubleshooting example. I also want to show you service bottlenecks here, so we could understand, well, what's going on here. It looks like a ton of time was spent processing in this local tier versus the next tier, and it definitely looks like we've had a network issue. So I might want to dig into what's going on in my network further. And of course, a troubleshooting, going down the deep troubleshooting path can be pretty tricky. So we'll reserve that for another time. The other thing you probably want to look at here, what are your top HTTP requests and how are they doing? So here we can look into those top endpoint requests. And so this is kind of a view that's very specific to looking at those microservices endpoints. Another user asked about stats-D metrics. So far I've been primarily using our dashboard views, but we have every single metric in your system, including custom metrics like stats-D. So you can see here, so we've got some stats-D metrics coming out of our Mongo environment, and you can easily look at those metrics and segment them by something like container ID. There you go. We can see both of those. Cool. Okay. In the few minutes we have left here, I'm going to keep going here because I want to get to these last questions around alerting and then additional questions in troubleshooting. So the other thing that you're going to realize as you're going through this process and you're like, wait a minute, I've now taken my app, and where I used to have this monolithic app that I could really understand easily where it's running, now it's hard to figure out exactly where it's running. So how do I rethink alerting to help me better understand the system? People used to use host resource metrics as a really good way to indicate that there was going to be a problem with an app. It's a very reactive method of thinking about the problem. Container resource metrics, well, they seem useful for troubleshooting, but if my app is spread out over many containers, it's not really going to tell me if something is truly going wrong with the app at large. It's going to tell me if something's going wrong with the container. Application metrics, that's starting to sound a lot better because it's closer to the user experience. But service-oriented metrics are the way you can make a really big difference. A service-oriented metric uses the same concept we're talking about before. Can I aggregate data across my entire set of containers that make up a service and leverage that data to alert on what the experience is like for my customer? So how do we do that? I think I said most of this. Yeah, I think I said most of this. So we'll skip the slides, hop back to the demo environment because that's more fun anyway. Let's say we want to create an alert off of something like this metric. We'll just do this as an example here. Just because it's convenient here. You can click on the alarm bell, which I just did, and you get our alert creator. And I want to focus on the important thing here. So first of all, you've got a metric, which you're going to define and set a threshold for. If you want to, you can use our baseline anomaly detection or our host comparison methodology. Don't have time to go into those, but they're pretty cool. Here's the important part. When you aggregate across your metadata, you're essentially creating one adaptive alert that grows and shrinks as you add more containers to a scope. So in this case, we're saying the Kubernetes deployment name is Mongo, and as Kubernetes decides to scale up your Mongo deployment and add 10 containers, the alert applies across the entire scope of it. You can also break it out by container. So you set one alert for the entire Mongo deployment and then say, but trigger an alert for each container that triggers my condition. You can also set notifications, and set notifications, someone asked earlier if you can take action with the data you see here. You can set notifications in a few ways. You can set notifications to go to Slack, but more Slack, VictorOps, email, PagerDuty, so on and so forth. You can also use a webhook. And so a webhook would allow you to trigger a system to take action. And then finally, you can activate a Sysdig capture. And a Sysdig capture is an incredibly powerful way to troubleshoot your system, highly differentiated. No other system on the planet has anything like this. When an alert is triggered, we will capture every single system call that happens on those machines in relation to those containers and give you a permanent record of what was happening at the system call level when the alert was triggered. Because Kubernetes and Swarm and Docker may be killing and moving containers, even when you are like, wait, stop, I need to troubleshoot this, you end up with a problem. How can you troubleshoot containers after they're long gone? With Sysdig Captures, you can actually do that. Really powerful solution. Let's go into a quick alerting workflow here. We'll hop into our events, our alert events here. And we can see we were getting some alerts here where the net connections were low. And let's go explore this event, right? So when we explore this, we can hop back in time. And this is interesting. Okay, so we see this massive drop-off in our containers. Pardon me. And what's interesting here is you're also seeing our event overlays. Events are contextual pieces of information that aren't metrics, but instead inform us what's going on in our system. So here we can see the alert when it happened. That's this red one. But let's look at this informational one right beforehand. Look at this. We have a Jenkins event where we started a deploy. So this is in our dev environment, so it's not really surprising that when that the developers tried to deploy something new, we had some kind of problem here, and then, oh, interesting, right over here we see a Jenkins rollback, and things start to go back to normal again. If we'd like to compare this across our prod environment, let's do this. Let's get rid of the namespace and add container ID as, okay, now we're looking at MySQL, and we're going to segment by container ID. And now we've got a comparison of our prod environment versus our dev environment. We can kind of verify that nothing went wrong with our prod environment. So there you kind of walk through an admittedly simple troubleshooting use case, but it started all the way from a service-oriented alert and allowed us to get down into metrics that kind of effectively allowed us to break down the system, understand it, correlate it with events going on outside of your metrics, and get to the bottom of a problem very quickly. Okay, so I've still got some questions coming in. This is a great opportunity for us to ask any last questions. Just a quick review of best practices here. So dynamic and transparent instrumentation. You should never instrument individual containers and never manually update instrumentation. Is number one. You should be monitoring application-specific metrics. Those would be out-of-the-box metrics, like some of those I showed you around MySQL and WordPress, or custom metrics like StatsD and JMX. You should be able to monitor microservices, aggregate the data across many, many containers into a service, and be able to establish the performance of services. And you should have an alert model that matches. Alerts per container aren't relevant, and alerts per service that adapt make the most sense. Okay, it's time for you to unleash your questions. Let's see here. Curtis was asking about a situation where cascading failure is diagnosed. It's very, very specific, Curtis. Hopefully my alerting workflow gave you an example of how you might approach a problem like that. Charlie asks about the comparison of Sysdig and AppDynamics. Yeah, AppDynamics is a great tool, a great APM tool. This is very specifically oriented to provide you with a container and microservices-oriented view of your environment. So we can do all of that without actually instrumenting inside your containers. With AppDynamics, you're going to have to put instrumentation libraries in every single one of your containers and your apps. Sysdig is going to give you a much cleaner view and take you all the way down into the infrastructure. In fact, what I would say is Sysdig starts from the infrastructure and goes up, where AppDynamics really stays at the application layer. We tend to be complementary tools. Satiris asks about alert analytics, like moving average and window functions. Yeah, actually, I didn't quite describe, I didn't do it justice in my alerting overview, but everything is based on Windows functions, and you can do averages, rates, mins, and maxes. Commercial name is Sysdig. Shri is asking, Sysdig.com, and someone was just asking about a trial. Absolutely. Go to Sysdig.com and sign up for a trial. You can just click a button, get a free trial right away. If you're interested in a trial of our on-premise software, which has a 100 host minimum, then you can email us at sales@sysdig.com, and we'd help you there as well. Let's see. Does this work with uncontainerized microservices? Galen, excellent question. Thank you for asking that. I feel like I should give you $20 behind the scenes or something. So our dirty little secret is we're talking here today entirely about Docker monitoring. Sysdig works great in non-containerized environments. VM and bare metal work perfectly well. So whatever you've got, we'll be able to monitor it. DP asks, what level of API support does it have? Our entire UI, everything you saw, is built on top of our API. So you have access to the exact same API endpoints that we do in our product. It's very robust. We, in fact, have already built a Python example client so you can kind of easily code around it. Samir asks, how do we compare this tool with open source monitoring tools? If you're, a lot of people fall into the build versus buy camp. Frankly, you're not going to get something as powerful and as well instrumented as Sysdig with any open source alternative. It's going to be a lot of work and probably a lot of frustration. So you can go down that path if you like. If you feel like your time is less expensive than the money that it would cost to run something like Sysdig. That's a choice for your company to make. Yeah, so certainly people go through that all the time. The thing that I warn people about is you need to do the build versus buy analysis. It's very rarely that building a solution as complex as this makes sense for you unless it's your core business. So we'll let you focus on building the software that matters to your business, and we'll make you go faster. Great question. Let's see here. Other questions, other questions. I also encourage you to check out the Sysdig open source tool. So if you're interested in an open source tool for troubleshooting containers, go to sysdig.org. And sysdig.org will provide you with a really powerful container troubleshooning tool. And that will really give you kind of a great way to understand what's happening in your on your hosts. Guru asks about cost around Sysdig. The billing is per host. We have multiple tiers. It starts at $20 per host per month, so it's very very affordable. Galen asks, oh, and by the way, Guru, we also do volume discounting. So as you get larger, we'll make it more cost effective for you. Galen asks, I may have missed it, but you mentioned JMX. Did you show monitoring JMX? Galen, no, you didn't miss it. I didn't show it. I think you'll have to take it on my word that we can do JMX. It looks exactly the same as looking at stats-D metrics, which I did show, and we get those all out of the box. The beauty with our custom metrics is you don't have to even recode them to point at a new endpoint. We will automatically find JMX metrics flowing through your system, even if they're currently flowing to another tool. It's pretty sweet. All right, last chance for any questions here. Last chance. Going once, going twice. 3 times, and I think we are sold. Thank you so much, everybody, for your time. I hope this was useful and productive for you. If you do have additional questions, you're welcome to hit us up at apurva@sysdig.com. That's me, info@sysdig.com, or just find us on Twitter. you can just find us at Sysdig, and we'd love to answer your questions. And talk is cheap, so I really recommend that you just trial this thing yourself. Go on to Sysdig.com, start a free trial right now. You saw how quickly it was to instrument a system. You can get going, and you can kind of experience the joy of Sysdig yourself. Chris, back to you.